Hello guys, welcome back to my YouTube channel. This is Bhagyalakshmi. Today we are going to discuss about lex and Yacc functions. Contents to be covered are what is lex, functions of lex, structure of lex and an example, and what is Yacc, functions of Yacc, structure of Yacc with an example. So let's move upon our first topic, that is what is lex. Lex typically refers to the software tool called lexical analyzer generator. Lex is a program generator that helps in creating lexical analyzers, also known as scanners, for programming languages. A lexical analyzer is an essential component of a compiler. It takes the source code of a program as input and breaks it down into a sequence of tokens. Tokens are the smallest meaningful units of a programming language, such as keywords, identifiers, operators, and literals. The lexical analyzer identifies these tokens by matching patterns defined using regular expressions. Lex is often used in conjunction with another tool called Yacc, which is yet another compiler. Yacc is responsible for creating the parser, which analyzes the grammar and structure of the program. Together, Lex and Yacc form a powerful pair for building the front end of a compiler or interpreter. The following are the Lex functions. The first one is tokenization. Lex helps in the process of tokenization by generating a lexical analyzer, also known as a scanner. The scanner breaks down the input source code into a sequence of tokens based on predefined patterns. Each token represents a meaningful unit in the programming language, such as keywords, identifiers, operators, or literals. Second one is pattern matching. Lex facilitates pattern matching by allowing developers to define regular expressions that describe the lexical structure of the programming language. Lex scans the input source code and matches the patterns specified in the lexical specifications. When a pattern is recognized, Lex triggers the associated action, such as returning the token type or value. The third one is lexical analysis. Lex performs lexical analysis by applying the generated lexical analyzer to the input source code. The lexical analyzer scans the input character stream and tokenizes it based on the defined patterns. It identifies and categorizes the tokens, discarding any whitespace or comments that are not relevant to the language's syntax. Now, let's move upon to the topic what is Yacc. Yacc, also known as yet another compiler, is a tool that helps in the construction of the parser, which is a key component in the compilation process. Yacc is often used in conjunction with Lex, the lexical analyzer generator. Yacc takes a formal grammar specification as input and generates a parser in a programming language such as C or C++. The generated parser analyzes the structure and syntax of the input program according to the specified grammar rules. The following are the Yacc functions. The first one is grammar specification. Yacc allows developers to define the grammar of a programming language or a specific language construct using a context-free grammar. The CFG consists of production rules that describe how symbols can be combined to form valid expressions or statements. Parsing. Yacc generates a parser based on the specified grammar. The parser processes the input program, breaks it down into a parse tree, and checks if the program adheres to the defined grammar rules. It detects syntax errors and provides error recovery mechanisms. Reduction and action rules. Yacc associates actions with the grammar production rules. When the parser recognizes a particular rule, it executes the corresponding action code. These actions can include tasks such as constructing an abstract syntax tree, performing semantic analysis, or generating intermediate code. Integration with Lex. Yacc works seamlessly with Lex-generated lexical analyzers. Lex handles the tokenization of the input program and provides a stream of tokens to Yacc, which in turn applies the grammar rules to determine the program structure. By combining Lex and Yacc, developers can construct the front end of a compiler or interpreter. Lex performs the lexical analysis, breaking the input into tokens, while Yacc handles the syntactic analysis, verifying the input against the specified grammar rules. This is the structure of Lex. So here we can see there's a definition section which starts and ends with the person symbol, and the rule section which starts and ends with two person symbols, and then the user subroutine section. The definition section is the place to define macros and import header files written in C. It is also possible to write any C code here, which will be copied into the generated source file. It is bracketed with percent. It is in this format. The rule section is the most important section. Each rule is made up of two parts, that is pattern and an action, separated by white space. The lexer that Lex generates will execute the action when it recognizes the pattern. Patterns are simply regular expressions. When the lexer sees some text in the input matching a given pattern, it executes the associated C code, and it is in this format with the brackets and double percent symbol starting and ending with these. The user subroutine section, in which all the required procedures are defined. It contains the main, in which C statements and functions that are copied to the generated source file. These statements presumably contain code called by the rules in the rules section. Now let's see a Lex program to recognize numbers. So here we can see there are three sections. Here the first section being the definition section, where we can find out by seeing single percent symbols. Here the header file is declared, hence is called as definition section, and then the next is rule section, where the patterns and actions are defined, are given. Here the pattern is 0 to 9 and the action is this. And then in the subroutine part, where we write the C program, in the main we print the value, and then yylex function, this is used to scan the statement, and then we use int ywrap, then we return 1. This, when it returns 1, it means that we can end the program. Otherwise, if it returns 0, then we need to keep scanning and insert another input file. After writing the previous code which we have discussed in the terminal, these are the commands we need to use. Lex file.l. This runs lex over the lex specification and generates a file, lex.yy.c, which contains C code for the lexer. Then the next command, cclex.yy.c. This compiles the C file. And the last command, this executes the C file, and hence we get the output. Now we will be seeing the structure of Yacc, where the definition section is there, rule section is there, where the grammar is present, and then auxiliary routines are present. So there are three sections. The definition part includes information about the tokens used in the syntax definition, that is person token number, person token ID. Yacc automatically assigns numbers for tokens, but it can be overridden. Yacc also recognizes single characters as tokens. Therefore, assigned token numbers should not overlap. The definition part can include C code external to the definition of the parser and variable declarations within the person symbol in the first column. It can also include the specification of the starting symbol in the grammar. The rules part contains grammar definitions and actions in C code in the parentheses. Auxiliary routines part. The auxiliary routines part is only C code. It includes function definitions for every function needed in the rules part. It can also contain the main function definition if the parser is going to be run as a program. The main function must call the function yyparse. So guys, now let's see the Yacc program to build a simple calculator. Here in the definition section, we are writing this code which is defining here the function to handle syntax error and lexer function, and as well as variables for parser and lex communication are given. Here we can see from here to here in the rules part there are nothing but the grammar rules present in Yacc. So these are the grammar rules. And then finally the auxiliary part where we write the main function. For compiling Yacc program, we need to follow these six commands given here. The first command being we need to write lex program in file.l and Yacc in file.y. These particular files we need to write lex and Yacc program particular respectively, and then in the second command we open terminal and navigate to the directory where you have saved the files. After that, we type lexfile.l. This is nothing but to compile the lex code we have written earlier. And then next we type yacc which is nothing but to compile the Yacc program we have written earlier. Then the fifth command is type cc lex.yy.c. Here it's important to keep in mind that there's a space here, and then y dot tab dot h, then there's a space here, then hyphen ll. Hyphen ll is nothing but this is linking two lists, that is the lex and the Yacc. We link these two particular files, so we link two files, hence two ll here are written. And then the output file is obtained by the command a dot out. So the output is obtained but it's invisible. So hence to make it visible we type dot slash a dot out, and hence after typing this we can open the output obtained. Thank you.